So these notes don't have too much math in them. It's a lot of definitions. So I already have the definitions here for you for all of these things on the first slide here, but I'm still going to go through them and just explain what they are. We're going to be talking about three-dimensional figures now, or they're also known as solids. So we're talking about cones and cylinders and prisms and pyramids and all different kind of stuff. And we're going to go through it all today. But the first two main areas, surface area and volume, we're going to do volume first. This whole test is on volume, and then after your project, then we'll go back to surface area. But I've defined them both here just so you know what they are. And the surface area is exactly what it sounds like. It's the area of the surface. So if you think of a three-dimensional figure, if you would be finding the area of every single side and then add all of that up, that would give you the total surface area for the figure. And that's still going to be in squared units, because it is just area, just like we've been finding of 2D figures, like circles and rectangles and triangles. So even though it's three-dimensional, it's still just the area, so the outer area. Volume is how much space a figure occupies. Or you could think about how much water you could put inside something. That would give you the volume. Okay, so that's our three-dimensional measurement. That's why our units are always going to be cubed. So if it would be a box, you would think, well, how much space does this box occupy? Or how much water could I put inside of this box? Okay? So we're going to focus this section on volume. That's what your test is going to be on at the end, and then we'll do surface area later. Now, just like we talked about shapes at the very beginning of the year and polygons, 3D figures are called polyhedrons, okay, or polyhedra would be the plural of that. But a polyhedron is just a solid bounded by polygons. That means there's no curves. So spheres and cones and cylinders are all not polyhedra, just like circle was not a polygon, okay? Polygons only had straight edges, and polyhedrons only have straight, flat edges. Now there's three different parts of a polyhedron. The face would be the flat surfaces, so the polygons. So if you're thinking of a box, again, you would have 6 different rectangles happening on all sides of the box. So those would be all of your faces. The edges are where 2 faces intersect. So that would be the segment. So you think the edges would be along the sides of all of the box. And then the vertex, those are the corners, where 3 or more faces intersect. So where those flat surfaces come together, they're going to be your corners. So here I have 3 different solids. Okay, we're just going to focus on this first one here. Okay, so is it a polyhedron? Yes, it is. Okay, we have no curves. Everything is nice and straight. Okay, now number of faces. Now sometimes this is a little tricky because remember these are three-dimensional. So the number of faces you think, remember this is our box, so we have a top and a bottom, that's 1, 2. A left and a right is 3, 4, and then the front and the back would be 5, 6. So there's 6 faces. The edges, remember those are our straight lines, those are our segments. So I have 1, 2, 3, 4, that's my front, 5, 6, 7, 8, that's the back, and then connecting them, 9, 10, 11, 12. So there's 12 edges there. And then vertices, or that's the plural of vertex, that's your corners. So I have 1, 2, 3, 4, 5, 6, 7, 8 vertices. Okay? I'm going to skip over to this pyramid for a moment. Okay, so again, is it a polyhedron? Yes, it is. Okay, because there's no curves, everything is nice and straight. Now faces, so I have this bottom pentagon, so it has 5 sides, so that's 1. And then if I think I have 5 different triangles coming off of those sides up to the point, so I have 1 triangle there, that makes 2 faces, 3 faces, 4, 5, 6. So it has 6 faces. My edges, 1, 2, 3, 4, 5. 6, 7, 8, 9, 10 edges. And the vertices, those are my corners. So 1, 2, 3, 4, 5, 6 different vertices. Okay? Now I left the middle one for last just because it's a little tough to tell because it doesn't show us what's happening. Like it doesn't have dotted lines here to show us what's going on in the background and all of that. Okay? So it makes it a little bit different. I'm going to erase those so we don't get confused. So, first of all, is it a polyhedron? Yes, it is. No curves. Everything is nice and straight. So my faces. So if I think, okay, I have the left side over here and the right side over there. That's 1, 2. I have the top and the bottom, which would be 3, 4. This front makes 5. I have a top up here that makes 6, and then if you think about this being an L shape, you have 7, 8 in there. So there are going to be 8 faces. The edges, I have 1, 2, 3, 4, 5, 6, and I'm going to have those same 6 on the bottom, even though I can't see them. So I have 6 at the top, 6 at the bottom, makes 12, and then all of the connections, 13, 14, 15, 16 we can't see, 17 we can see a little, and 18 we can't see. But there are going to be 18 edges. And I know that's a little bit tricky sometimes because, again, it is three-dimensional, so it's hard to see all of them. But you just have to think about what it would look like. And then the number of vertices. So 1, 2, 3, 4, 5, 6 on the top, and I would have the same 6 on the bottom. I can only see 3 of them, but I would have another one about there and then 2 more over there. So 6 on the top, 6 on the bottom makes 12. The main type of solids we're going to be looking at are prisms and pyramids. And they're very close to one another in what they look like. And here I have a triangular prism. The reason why it's called a triangular prism is because these two sides are triangles. And this would be called a square pyramid, and that's because the bottom here is a square. So this would be a square pyramid. And this would be a triangular prism. Now, how do we know if it's a prism or a pyramid? Well, the number of bases will give us a good hint. So this one has 2 bases. Prisms always have 2 bases, and a pyramid only has 1. Okay? My base here is just a square. I only have 1, but I have 2 triangles. Now, lateral faces. That's talking about all of the other faces that are happening. So between the 2 triangle bases, I can see I have rectangles. I have 1 rectangle there, 1 on the bottom, and 1 over on that side. So these are rectangles. But in a pyramid, my other faces are all triangles because they're all coming to a point. So I have a triangle happening on each base. So in a pyramid, your lateral faces are triangles. Now, the edges, and what this means, it's not the number of edges, but it's more what are the edges doing. Well, the edges in a pyramid, they all meet at a common vertex, which sometimes it's called the apex. So all the edges are going up here to meet at this apex at the top. They're all meeting at a point. The edges here just match up corresponding vertices to the bases. So if it's a triangular prism, you'll have 3 edges that are all going from one base to the other. So they're just connecting the bases. So there's connecting the bases together. And finally, cross sections. What that means is if I were to cut this in half, right there, if I was going to cut it in half and look and see what's happening there, this cut would be another triangle. It would look exactly the same as my other two bases. So all of your cross sections are going to be congruent to the bases. I guess I should say to the bases here. So no matter where I make a cut, if I were to cut this anywhere along here, all of those cuts would look exactly the same. They would all be triangles. However, if I would cut here on a pyramid, they're all going to be squares. Like if I would cut the top off here, it would be a square, but it's not going to be the same size. Instead, this is going to be similar, which we already talked about similarity, but it's going to be similar to the base. So it's still going to be a square, but those squares are going to get smaller and smaller and smaller and smaller and smaller the closer that we get to that apex at the top. So that's the main difference between prisms and pyramids. Really, you can just look at the number of bases. If it has two parallel bases, then it's a prism. If it only has one base with the point, the apex at the top, then that's a pyramid. And the last thing I just wanted to go over were the three solids that we are going to look at, but they're not considered polyhedra because they have curves. So you can see down here it says these are not polyhedra, but they still do get names. A sphere is just a ball, okay? And it's a solid where every point on its surface is an equal distance. So that just means here I have a radius, but anywhere I would draw that radius, it's going to be the same distance, just like in a circle. Now a cylinder is basically a prism, okay? It has two circle bases and the sides are parallel. It would connect them. And if I were to cut this in half or cut it anywhere along here, those would all be circles that look exactly the same. So it looks like a prism and it acts like a prism, and you'll see when we do our formulas, it's the same formula as the prism, but it's not technically a prism because it has curves. And then a cone is just like a pyramid, only its base is a circle, but it still meets up here at the apex. And the same thing, if I were to cut it along here, all of those circles would keep getting smaller and smaller and smaller towards the top. So again, it acts like a pyramid, it looks like a pyramid, but it's not technically a pyramid because it has curves. Okay? If you have any questions about any of these definitions or how to name them or anything like that, make sure that you ask me.